Good evening folks. Today we are going to discuss how to develop our word count example. Okay, now I'll start with a simple file. Let's say I have a file called word1.txt whose size is 1 kilobyte. So since 1 kilobyte is lesser than 64 MB, so we will have only one block. We'll have only one block, and when we try to process this file by using MapReduce program, only one map slot is needed because the file size is very less. Okay, so I'll say map slot will process our mapper class. We will write that mapper class. Okay, and inside this mapper class you will have a method called map method where you are supposed to write the functionality what you want to do. Okay, now as per our example intention is I would like to find out the total word count of each and every word. Okay, so in the map, this is my input file word1.txt. This is my input file. Okay, this input file will be given to our Hadoop framework. Now Hadoop framework will give this word1.txt mapper, but as we know that in case of MapReduce programming, everything should be in form of key and value pair. So what will be the format? What will be the input format expected by mapper? Key and value, is not it? So as we have discussed earlier, the key will be, as we have discussed earlier, this file data will be converted like this. I'll say 0, and let me say 35. Okay, and let me say 45, or let's say 55. All right, so what is the data type of this key? What is the data type of this key? Integer. Okay, integer. Yeah, what is the data type of this value? String. Okay, now these numbers are actually called as offset. Okay, these numbers are actually called as offset. All right, and this will be the input to our mapper. Now in our input file, how many lines we have altogether? 3 lines. So how many times the map method will be called? 3 times. So map number 1, first time. Okay, first time the key will be 0, the value will be apple ball, is not it? Now what is our intention? Our intention is to find out the total number of words. So what we will do, we will just write a logic like this: say apple is 1, say apple 1, say ball 1. Right, the first mapper will emit this output. The first map method will emit this output. Next, again the map will be called for second time, is not it? This time 35 is the key and the value is ball, orange, apple. So what it is going to emit? Ball 1, orange 1, apple 1. Again the map method will be called again for the third time. Okay, so it is the Hadoop framework which calls the map method again and again. Let's assume Hadoop is a main method. Okay, Hadoop is a Java program which contains some main method. Now from that it will create the object of mapper, and from that mapper class it will call map method for each individual line. Okay, so after completion of these three, we will have all output like this. This is the output from first, this is the output from second, right, and the third output will be apple ball, same. right? So after your mapper, all the mappers are done, all the mappers has completed its work, you will get the output like this. Now what is the next step? Yes, the next phase would be sorting. So what will happen? This apple will be together, grouped together. I'll say group phase, not sorting. We'll say group phase. Apple, 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 apple. 5 times. So 1, 1, 1, 1, 1. So apple is grouped. Now what is the next group? Ball. Ball 1, ball 1. How many balls we have? 2. 1, 2, 3. So ball 1. Okay, now what else we have? Apple, ball and orange. Orange only 1 time. Orange 1 time. So this is the next phase, right? Group phase. Sorry, yeah, it's group phase. No, I'll say shuffle phase, basically shuffle and sort phase I'll say. Okay, and then the group phase, because in group phase it has to be grouped, right? What will be the output of this group phase? What will be the output of this group phase? What will be the output of this group phase? Yes, apple, and then 1, 1, 1, 1, 1, right? Ball 1, 1, 1, orange 1. Is not it? So here also see, this is the key, this is the value, and finally after this which phase will come? Reduce phase. After this which phase will come? Reduce phase will come. Okay, now in the reduce phase, you will get this as a key and you will get this as a value. Okay, you will get this key as a key and you will get this as a value. Alright, so here key is string, value is array of integer. For the time being I'll say array of integer. Okay, now once you get access to this value, it is our logic, right? Our logic, we have to write the logic to get the value from integers and do the summation. So we will add it manually: 1 plus 1 2 plus 1 3 plus 1 4 plus 1 5, and finally we will write like this: emit apple occurred 5 times, emit ball occurred 3 times, emit orange occurred 1 time. Are we clear on our goal? Okay, now so just I want a few more clarification. Word.txt, word1.txt. Okay, so it contains only string, right? Data is in form of string. Okay, so this data will finally come to whom? Mapper only, right? So mapper input, what will be the key and value pair for mapper? I'll say input key value pair for mapper. What will be the input key value pair for mapper? Data types. I just want data types. Key and value pair. Integer is the key, okay, and string is the value. Okay, good. Now mapper will do some work, right? Mapper is going to do some work. And what is the sample mapper is going to emit? Can you give me an example? what exactly the mapper is going to emit? As per our data sets, as per our data, what is the value mapper is going to emit each time? Not 0 apple, it is apple 0, apple 1. Okay, so output key value pair from mapper. What is the output key value pair from mapper? What is the key and what is the value? String is the key, okay, and value is integer. All right, perfect. Now this will go to shuffle and sort. Is not it? This will go to shuffle and sort. Now this output will be the input to shuffle and sort. Right? This output will be input to the shuffle sort. What will be the output from shuffle and sort? Input key value pair for shuffle and sort will be string integer. No, that the array will come after your group by, right? Group, I am not talking about group now. So output will also be same, is not it? Output will also be same. It will just sort the data. It is not going to do anything on it. It is just going to sort the data, is not it? Like our data was like this. We gave it to shuffle and sort. The shuffle and sort is going to give us the same data, but in a sorted order. Am I right? Okay, then the output of this shuffle and sort will go to group by, is not it? So input key value pair for group by. What will be the input key value pair for group by? The output of this. Okay, now this will give me some output. What will be the output of this? What will be the output from this? The output will be string and integer array. Okay, the output will be string and integer array. Next, now this output will go to whom? Reducer, right? So input key value pair for reducer. What is the input key value pair for reducer? The same thing, string and integer array, is not it? String and integer array. Next, now our reducer will do some calculation and it will give us some output. What will be the output value pair for this? What will be the output value pair from reducer? What is the final output you are going to get? Apple 5 times, orange 2 times, like this, right? So string and integer. Are we clear on this? So idea is the data is here and it goes through various phases. Input to mapper, output from mapper goes to input to shuffle and sort, output from shuffle and sort will go to group by, output from group by will come to reducer, output from reducer will be the final result. Are you getting my point? Okay, now next thing, while working with Hadoop programming, okay, we are not going to use this string. Okay, we will, instead of string, Hadoop has its own data type called as text. Okay, instead of int or integer, okay, Hadoop has something called int writable. Instead of long or long, Hadoop has long writable. Okay, and so on. So we are not going to use this string in Hadoop programming. Alright, so mostly we will deal with text while interacting with Hadoop framework. Internally, when you try to write some logic, it's okay, you write logic as string, but this string will not be a key, will not be a value. Getting my point? In the logic, you can write string s equal to xyz, but when you emit the data, when you produce the output will not be produced in string format, the output will not be produced in integer format. Output will be produced in text format, and output will be produced in int writable format. Are you getting my point? Okay, that means in this whole transition, okay, instead of integer you say int writable, instead of string you say text. Alright, so to make you understand, I said integer and string, but in the real scenario, it will not be integer, it will be int writable. Instead of string, it will be text. Okay, we will see the data types in Hadoop, we'll talk later, but first of all, let's understand a very simple word count example. Are we clear? Okay, now let me directly jump into the example. Alright, now let's try to understand how to write a simple MapReduce program. Okay, so you right click on the Eclipse IDE, new, others. Alright, you choose MapReduce project, you choose Java project, one and same. The only difference is, if you choose Java project, you have to manually arrange the jar. If you choose MapReduce project, you will get all the jars. _2 word count MapReduce basic, say finish. Yes. Okay, done. Next what you do, we are going to write Hadoop programming. That means we need some Hadoop related jars. Yes, so yesterday we figured out 4 jar files, right? So that may not be sufficient. Okay, that may not be sufficient, so you need to deal with 6-7 jar files. I'll tell you that. So these many jar files, are you able to see the screen? Commons CLI, commons logging, commons HTTP client, JSON, these many jar files you need to gather. Okay, from where to gather? This one you will get it from Hadoop Home, this one you will get it from library. So let's go and pick it up. You go to computer, you go to user, local, this is the place where we have installed Hadoop. Go inside Hadoop. Now Hadoop core unit, copy this and let's create a folder called lib. New folder, right click and say paste. Done. Now again let's find out some other jar files. You directly go to library. Okay, if you don't want to do that, copy all and paste it on your project, but that really will not make any sense. So let's hunt one by one. Common CLI, common configuration, common CLI here, common configuration here. Okay, then commons logging, log4j, commons logging, and then log4j. Where is my log4j? Log4j here. Okay, next commons HTTP client, commons LAN, HTTP client, commons LAN, Jackson Core ASL, Jackson Mapper ASL. Jackson Core ASL, Jackson Mapper ASL. Copy this. Move to paste. Okay, so altogether how many? 1 2 3 4 5 6 7 8 9. 9 jar file you need in your class path. Okay, so we have just created a folder called lib. Okay, will it really add it to the class path? If I just create a folder called lib and if I add my jar files there, will it really add it to the class path? No. Okay, why we have done it? So that tomorrow when we take a backup of this project, along with my project, along with my code, I'll also get the libraries here. Okay, so the next step would be you right click and configure this. Configure to build path, add jars, proceed to lib folder and select all. Say OK and say OK. Done. It is added in the class path. Now next, in your MapReduce programming, okay, in your MapReduce programming by default you will have 3 resources minimum. Minimum you have to write 3 resources. One is your map class. Okay, I'll say mapper class. Second one is your reducer class. Okay, and third one is your main method class. We call it driver program. Okay, we call it driver program. So we have to write our mapper, we have to write our reducer, we have to write our main method. Now let's start with writing a mapper. Writing a mapper is very simple. Right click on this, say new class, package name. I'll create a package called P1. Let me create a package called P1. Class name, my mapper, anything you can give. Finished. Okay, so this is your mapper class. Extends map, mapper, Control Shift O. Okay, extend mapper. Now this mapper has got a map method. Okay, so this mapper has got a map method. You override that. Is the screen visible? Are you able to read the words, or do you want me to enlarge it? Let me enlarge them. Alright, now in this mapper, what is the input to this mapper? What is the input to this mapper? What is the input to this mapper? Line number is of which data type? Line number is of which data type? Int writable. Okay, next then this is the key. Yeah, the value will be text. Next, what will be the output from this mapper? Apple 1, that means text and int writable. Control-Shift-O, Apache IO text, finished. Okay, once you are done, delete this method. Okay, again say map, so that you will get the data with proper value. Done. So our mapper is ready. Now in this mapper you will receive the key and you will receive the value. Once I just wrote map, shortcut is like I just wrote map and I press control enter and go to your map method and say enter. Okay, next time I'll also tell you the shortcuts, no problem. Yeah, so this is the map and here you will get the lines. Okay, now similarly let's write our reducer. We'll write the logic later. Let's write our reducer now. New class P1 package reducer, say finished. I'll say my reducer. Okay, extends what? Reducer. Control-Shift-O. Okay, now what is the input to this reducer? Apple and array, some sort of array, right? So we'll say text comma int writable but iterable of. Okay, we will not write array, although we said array, but it is actually an iterable. Next, what will be the output from this reducer? Output from this reducer, apple 5 times, orange 5 times, that means text and int writable, is not it? So text int writable, save it, Control-Shift-O, io.text, finished, done. Now you write your reduce, red control space, okay, click on this, it has come up. I don't want this big line. Alright, now let me go to my mapper. Okay, text, this is my reducer. Let me go to my mapper. Okay, so this is actually your key, this is actually your value, right? So instead of value, let me just write line. context, it looks good. You can say offset, although you can continue with the same name, that is not a problem. Now here reduce, here I'll say word for each word, and here I'll say value, and let me say ctx context, saved. Done. So far we have developed our mapper, we have developed our reducer. Logic we will take care later. Now what is left? What is the next action item? What do we need to write next? Mapper is done, reducer is done. Next is, no, we are not going to write any shuffle and sort logic, okay, those group by logic we are not going to write. That will be taken care, that will be automatically taken care. So as a Hadoop developer, you just need to concentrate on these three for now. Okay, so the main method class, or we will call it driver program, we need a driver program. So I'll just right click here, new, class p1 package, I'll say my driver. Finished. Okay, now it will not extend anything, this class will not extend any mapper, no reducer, nothing. So here you add your main method, main main, control space, enter, save. Right, now here you have to link this mapper and reducers. Here you have to link this mapper and reducers. So there is a sequence, let's follow that sequence. I'll go to this file. Let me just go down. Okay, so how to prepare your driver program? The first step is you prepare your configuration object, create an object of configuration class. Do you remember yesterday we had created configuration object? So step number 1, create a configuration class pointing to default configuration. Paste. Control Shift O. Control Shift O. So whenever you choose this import, be very careful. Choose only Hadoop related configuration. If you choose any other configuration, you will mess up the program. Done. Next, what are we writing? We are writing a MapReduce program, right? So in that we have a class called job, which will take care of our MapReduce job. We will submit this job. Who will take care of this job? Job tracker. Is not it? So you can assume that this job is nothing but a representation which will give direction to our job tracker. So you need to have a job class object, okay, which will actually take care of your MapReduce programming. Prepare a job object. Job equal to new job, configuration, my word count job, nickname, a name for a job. Because when you write your MapReduce program, when you deploy your MapReduce program on cluster, there will be n number of programs developed and deployed by other teams. So this will give you a very unique identification to your program. Control Shift O. MapReduce.job. Finished. Save. Throws exception, I'll say throws. Save. Done. 2 steps are done. Next, link your driver class with the job. Okay, link your driver class with the job. So I'll copy this. Paste. Link your driver class with the job. Okay, that means when I execute this job, okay, there is some command to execute the job. When I execute this job, the job should understand, okay, this is my main class and I should start from here. Getting my point? Because this class contains the main method, right? So we need to tell our job object that, boss, my driver is a class which contains main method. You start executing from there. Done. Now next, you link your mapper with job, and similarly you link your reducer with your job. Okay, so are we clear till now here? What we have done? We created a configuration object. Why did we create configuration object? Because we need to create a job object. So we created a job object. Then we have started linking driver, mapper and reducer to it. Any confusion here? Okay. Next, now you have to set the final output key and final output value type. Okay, why I will tell you later. Set final output key. Now what will be my final output? Apple 5 times, orange 2 times, is not it? So what will be my key? What will be my key? What is the data type of my key? Text. Never say string, okay? Always say text. Okay, and what will be the value? Int try table, right? So int try table. Control Shift O. Done. So far we are good. So we added the key, we added the value. Next, you define your input and output path. Okay, next you define your input and output path. Control Shift O, FS path. Next, MapReduce, MapRed and MapReduce. See, MapRed is the old API related class. Okay, MapRed, never choose MapRed, always choose MapReduce. You'll get the same file. These files are removed. These files are moved to this library, this package now. So always when you get conflict, MapRead and MapReduce, always choose MapReduce. Done. So now we are going to run our MapReduce program on some data set, right? We are going to process this logic against some file, is not it? So that file should be present in our SDFS cluster or not. Whatever program we write, we are going to work on some data, right? Apple, ball, there will be some file like index.text or word1.text. So you have to provide the input path input directory is equal to new path of SDFS some location. Okay, now after this you say file input format add input path. So what it will do, on this job it will tell, hey job, whenever you execute, you try to take input from this location. Alright, we already discussed this path. In case of normal Java we say file, in case of our Hadoop we say path, is not it? Now once the processing is done, it has to write the data in some output path. Okay, where the output will be written? In SDFS only. The output will be written in the SDFS only, is not it? So you need to set the output path also. Okay, path output directory equal to new path. When you only say path output directory equal to new path, it will not really set any path, because it is similar to a variable declaration, a string declaration. Now after that you just need to set the path saying that file output format dot set output path job output. So the meaning of this whole line, the meaning of this line is, we are instructing job to take the input from this path. We are instructing the job to write the data into this output path. Clear on my point? Your input path should always reside on SDFS. Okay, so you have to change your path accordingly, because in Hadoop when you want to process the data, the first step is you have to move that data, you have to copy the data into SDFS, is not it? So you have to change this value accordingly. If your input is in some other folder, you just make the changes here. Okay, and then finally you complete your job. See, this is the way to execute your program. To run your program, you should say job dot wait for completion true. So it will return you a boolean flag. Now based on this value you can understand whether the program got successful or we got some failure. So in a one line we just wrote this command. In one line what we wrote, job dot wait for completion, it will return me either true or false. Okay, if true, 0, that means program completed successfully. If any problem, then 1. System dot exit 0, what it will do, it will kill the JVM and it will terminate the program, is not it? But 0 means the program got terminated successfully, 1 means the program did not get terminated successfully. Clear? Yes, the input path and the output path will be always into SDFS. Okay, reason is very simple. You are going to deal with big data. The input file size may be 1 terabyte. Okay, and the output file size may be 300 GB. And who knows, you may have that much space in your local hard disk or not? And moreover, do you remember in our yesterday's class we learned how to copy the data from SDFS to local and local to SDFS? Okay, see, assume that you are going to process a data of 10 terabytes. Input file is of 10 terabytes. So is it possible for you to store that 10 terabytes in a local file system? No. But if you have SDFS, SDFS will store file in distributed format, right? If you have 200 nodes, easily it can manage those 10 terabyte of data. Okay, and now after your MapReduce gets the process, after the MapReduce processing is completed, the output file, the input size was 10 terabyte, the output size may be 2 terabytes, depending on how much result you want from the data. Okay, so if it goes 2 terabytes, again, will you be able to store it on any file system? You may or you may not, right? You may not. Generally, who is going to store 2 terabyte of data in file system? So that is the reason, okay, in your MapReduce program, the input file path will be always SDFS and the output file path will also be always SDFS. Once that is done, then it is up to the programmer what he wants to do. Let's assume the input file data is in SDFS. You did the processing. The output file is again stored in SDFS. Now yesterday we learned the Java program how to copy the data from SDFS to local, is not it? So you follow that program. Alright, so let's recap once again this driver program. It is very important. The first step is create the configuration object. Okay, because if you don't create the configuration object, you will not be able to create your job, is not it? Next, then create your job. Next, once you create your job, you link your mapper, you link your reducer, you link your driver class. Okay, then you define your output key and output value, why it is needed. If you don't do this, okay, the default key and the default value is something else. We will see that later, okay, but it is not text and iterable altogether. Okay, so the key and value by default is considered something else, whereas our actual data is in text and iterable format, is not it? Apple 5 times. That is the reason you are supposed to specify it. If you don't specify it, then there will be some problem in conversion and you will get error. Okay, then you define your input path, you define your output path, okay, and you tell your job that please check the input from this location, please write the input from to this location, and finally you say job for wait for a completion, so it will be executed. Are we clear? All right, now it's time to format our files. So let me go to MapReduce, and I think my cluster is not also running. So first thing, we have to run our cluster. JPS not running. Start all. If you don't run this cluster and if you try to check this DFS location, it will give you error. JPS. Make sure all your 5 daemons are running. Okay, now let me go here, let me go here, let me go here. Okay, now tell me what is the input path, what is the input directory name? What is the input directory name? Yes, look into the code. What is the input directory name from where our data will be processed? Input data only. Okay, and where exactly it is present? Is it present in the root or is it present in inside SD user? Yes, root. Otherwise we would have written /user/SD user. So as per this requirement, I need to have a folder here. Okay, F5. All right, input data. Now output data directory you don't need to create. Okay, now I must place one file, some data here, is not it? Some file I have to put it here for processing. Okay, so let me go to desktop. I'll edit this. Apple, apple, ball, apple, ball, apple, orange, cat, dog, 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 save. All right, so this is my data. I would like to upload it. abc.txt. So go to Eclipse, input data, here right click and say upload file to DFS. Choose desktop, choose ABC, say F5, data is uploaded into SDFS. Confirm that. Hadoop fs -ls / input_data. Right, we have abc.txt. Looks good. I'll close this now. Next, now everything is perfect except our mapper and reducer logic. We have not written that, is not it? So here is my mapper. Okay, now let's assume I don't know anything about Hadoop. I just say sysout, okay, line dot to string. Let me convert this line into string. Okay, string current line equal to line dot to string. Current line. So what it is going to give you output? It is going to give you output like this. For the very first time, this will be the output, right? Is not it? For the first time, what will be the value of string? What will be the value of this current line? This only, is not it? Because the mapper will read the data line by line. Yes or no? We have already seen that here as per our example. Right, mapper1 will give me some value and the data. So I'll do like this, I'll convert this into string, okay, and then let me print this so that we can understand later. sysout inside map method, okay, my mapper is the class inside map method, okay, offset is equal to offset plus okay, and then my current line is equal to current line, Control A, Control Shift F to format. Okay, now I'll get this value apple ball in a current line. Now what is the next step? I have to split it, is not it? I have to split it, right? So you write like this, string word array is equal to current line dot split. Split method is there which accepts one argument, in it will return you string of array. So split of getting my point. What it will do, it will just take this first line, okay, and it will split that into an array. So after this you will have how many elements in these words? After this how many elements you'll have in these words? 3 elements. First element contains second element contains, third element contains. Okay, now what we need to do is we need to emit apple 1 ball 1, is not it? So let's iterate through this array. What is the best way and shortest way to iterate through this array? Other folks, please try to participate. What is the best way to iterate through this words array for each? Right, so we'll write it like this, for string word, current word, words, the list. Okay, so here word means this for each will iterate for 3 times, and every time you'll get the current value of the word, right? So 3 times. First time word value will be apple, second time word value will be apple, third time word value will be ball. Okay, and we are supposed to write what? 1 1 1, is not it? So here you write, you have a context object here, use this, paste dot write. Okay, we'll see what is this context object, we'll see later. Context dot write word. What is the type of word? String, right? But in the Hadoop, will it understand string? It will understand text. So we will create a text. See this, new text of word. We created a text, right, out of the word. Next, what I am supposed to emit here? Word apple I emitted. Now next is 1 1, and what is the format of that? Int writable. So can I say like this, new int writable of 1? Is not it? So you can also do it like this. Why should I create objects every time? So you can simply say here a final variable. You declare a final variable and you place it here, because every time it is going to write only one only. Okay, this is done. Save. Now our mapper is completed. Okay, our mapper is completed and it will come to the reducer. So what we are doing here is, we have written our map method which will process line by line. For each line we have split the data into array, and then we are going through each word present in that array and we are simply emitting it, context dot write. So what is this context? Context is nothing but, I can say, a kind of global variable, a kind of global memory. When you write data into the context, okay, it will be available to other components of your MapReduce programming. Okay, the mapper output should go to the reducer ultimately. The map method does not have a good return type. That means there should be one or other way so that the map can return some data to the framework, is not it? So the API says you write it on the context, we will collect it from the context object. Okay, done. Now once this is done, then your shuffle and sort will come, group by will come, and finally it will come back to our reducer. Okay, so in this reducer you will get word as a key and you will get that array as value. Okay, so let's write key is equal to word. That means for each fruit or for each word you will get, for each group it will be processed, right? So let me take one example for this reduce method. This reduce method will come for each word apple 1 comma 1 comma 1, right? For each group one reduce method. So you'll get the word here. Next, now we are supposed to iterate through this iterable, is not it? So what is the way to do that? You can say iterator it is equal to value dot iterator. 1 minute, what it returns? Iterate. This one. Same. So what we are doing is, we are trying to get access to this data, okay, using it. Next, while it dot has next, okay, do you have any next element? Yes. If yes, then it dot next, it will give you object. Okay, but actually it contains int writable, so typecast it. Okay, Control Shift O. One minute, it is int writable. I'll do it like this. We'll take generics here. what it is saying, cannot change cast to iterative. 1 minute. Iterable or iterator, there is a mistake here. Okay, there is a mistake here. 1 minute, there is a mistake here. We are not supposed to write the whole iterable. We are not supposed to write the whole iterable. We are only supposed to write int writable, and here it will automatically come. Save, Control Shift O, save. Okay, text int writable only you write. You don't write the array iterable. You don't write. Right click and just generate the reduce method. Okay, and it will come, iterable will come by default. Context ctx, text is word, yeah. So this is the actual format. Next, now we need to iterate through that. So I'll say iterator better, I'll make it. Okay, iterator it is equal to array dot iterator. Next, now while it dot has next, do you have next value? Yes, it dot next. Okay, now you convert it into int writable. Okay, now once converted, you try to get it in the integer format, I dot get. Okay, so what I'm trying to do is, I have an array like this. I have an array kind of data structure here, iterable, okay, which is pointing to this array, which is internally pointing to this array. So we created an iterator object, and for each element we are iterating, and I'm trying to get this value. Okay, internally Hadoop will store this data in int writable format, but to add that I need it in the integer format or not. So that's the reason I have converted typecasted into int writable, and finally I am saying I dot get. The return type of this get is int, int. So I'll do it like this, int count equal to 0 for the first time. Okay, so here I'll say count is equal to count plus I dot get. Okay, even you don't need to do this, these two steps you don't need to do this, because we are sure that it always contains 1, right? So shortcut, in a shortcut manner, while loop you use and just write count plus plus, is not it? That will also help us, because in this element, in this arrays, we don't have any other element, we don't have any other value than 1. Getting my point? So you don't need to exactly get this data and commit that. You just use this iterator, you just use this loop, and somewhere you say count plus plus. That will also do the work. Okay, so once this is done, next is you just write it down. Context dot write. What is the key here? Context dot write. What should I write here? Yes, context dot write. What will be the output from the reducer? Yeah, new text of, you can write like this, otherwise not needed. Word is then as a text format. okay, ctx, and value should be new int writable. Count. That's all. Okay, so the idea is, in the reducer you will get the data in this format for each group and the total 11111. Okay, now we are basically interested with this data, so we use this iterator to iterate through each of this element. We retrieved one, we retrieved one, we retrieved one, and we started summing it up, and finally the total count is your word count, is not it? So this is also done. Now the next step is execute your program. Okay, so let's go to our driver, right click on this and say run as Java application. Got some exception, let me check. Long writable cannot be typecasted to int writable. In which line? My mapper Java 1. Okay, the offset is basically of long writable type. Control Shift O. Done. My driver, let's run it again. This time what is the error? Output directory already exists, because last time we processed it has created an output folder. Okay, so F5 output data. Let me delete this. Again run as. Again some error, let me check. Type mismatch in the key from the map. 1 minute. Expected is int writable and received is text. This is for mapper. Mismatch in key, not value, key from map. Okay, expected is int writable and we received text. Offset and the whole line. And offset and a whole line and text and int writable. Apple 1 looks good to me. A type mismatch in key from map. From map key is text. Okay, I'll do one thing to just compress it. Let me just write it like this: job dot set map output key. Okay, job dot set map output value. So the output key from map will be output key from map apple, that means text. Okay, and the output value will be 1, apple 1, so it will be int writable dot class. Alright, let's run it again, but I have to delete this folder. F5 delete this, say OK. Now right click and run as Java application. Okay, So this time we did not get any exception. Okay, so ideally that exception was due to the input and output format. If you don't give it properly anywhere, if you miss that, you will get this kind of errors. Alright, now here we did not get any error and our program got executed successfully. Let's go up. Okay, and now you check your output. MyMapper.map offset is 0. First time the offset is 0. Next time the offset is 18. Okay, again next time the offset is 35. Again next time the offset is 73. So let's try to understand this offset. 0 is this one. Okay, the 0th position. This is the 0th position. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17. Okay, so maybe it is concluding from here. 1 2 3 4 17 and this is the 18th. Again you count this and here you will get 35. Again you count this and here you will get the 73. So did you understand how these offset values are calculated? And how many lines we have here? 4 lines. So our map method got executed for 4 times. 1, previously 1 is gone. 2, 3, 4. Is not it? So once that map is executed completely, then we'll get what? Reducer. We have not written anything on the reducer, looks like. Okay, what I will do, I will write here 𝗟𝗲𝘁. Okay, word dot toString key and value. Okay, I'll just say ARR. I'll try to print the ARR only. Alright, now my location, this one, say F5. Remove the output folder, say OK, right click, run as, go to driver, right click, run as Java application. Okay, it is not giving toString properly, so I'll go here and let me print that here. That will be good. What I'll get from here, I don't need these things. What I'll get here, and then let me have sysout i.get. Okay, so go to here, say F5, output data, and delete this. Now again run your driver program. Okay, go up. Okay, you see Apple was the data, Apple was the group name, and the value was all ones. Is not it? Again, the ball was the word name and the values were 3 ones. Cat was the data word name, value was 1. Dog 4 ones, orange 1 ones. So once this is done, your program got executed. The data will be written in this folder, output data. You go to this location, say refresh F5. Okay, now go to output data. So for all your MapReduce job, each and every MapReduce job, you'll get two files at least. One is underscore success, that means your job got successful. Okay, it has no data inside it. The real data will be there in this file, part underscore r underscore 0000. What is the meaning of r? R means reduce. Okay, so by looking at this file name, you can understand only map got executed or map as well as reducer got executed. So open this file. Apple for 6 times, ball for 3 times, cat for 1 time, dog for 4 times, orange for 1 time. Getting my point? Alright, so this is your first MapReduce application. Now I would like to tell you one more point about your MapReduce job. Are you able to see the screen? Okay, now consider that I have more than one file for processing. Okay, word1.txt, word2.txt, word3.txt. So word1 size is 70 MB, will be splitted into how many blocks? Word2.txt 5 MB, how many blocks? Word3.txt 150, how many blocks? 3 blocks. So we will not call blocks, we will call split. Do you remember the difference between block and split? Split is with boundary checking, is not it? Block is without boundary checking. Split is with boundary checking. So split 1, split 2, split 3, split 4, split 5 and split 6. And assume that you have a 3 node cluster. Okay, 3 node cluster. So how many map slots you will have for each cluster? How many map slots, how many reducers slots in each node? 2 map and 2 reduce, right? So see, this is a cluster, a slave master. Data node will monitor the data, and this is a task tracker. Task tracker will have map slots and reducer slots, right? And it executes the data by using task instance. So same thing here. Now split 1 suppose is been processed in this block. Split 2, let's say it has been processed in this map slot. Split 3 will be processed in this slot. Split 4 is processed here. Split 5 is processed here. Split 6 will wait because it does not have a slot free. If needed, the framework will assign this split to be processed by this map slot. Getting my point? Since this map slot is free, if needed, the MapReduce framework may assign this slot to process this split. Okay, now mappers will be executed here. Our map method will be called. Okay, our map method will be called. But now once the map method is called, then shuffle and sort, then group by, after that reduce, right? After that reducer will be called. So by default only one reducer will be called. Getting my point? So the output of this map slot, the output of this map slot, the output of this map slot, output of this map slot, output of this and this map slot, all this output will go to your sorting phase. It will be sorted, okay, and then it will be grouped by. After grouping, it will be sent to a particular reducer. Okay, so by default only one reducer will process your data. Okay, and did I talk about data local optimization? Did I talk about data local optimization? I think I did not talk about that. Okay. Now let's assume that you have three nodes, node 1, node 2. I'm talking about the slave nodes. Alright, and let's say block 1 is present here, so big. Okay, let's say block 1 is present here. Let's say block 2 is present here. And let's say block 3 is present here. Block 3 is also present here. Okay, block 2 is present there as well as here. Block 1 is present here. Assuming replication factor is 2. Okay, assuming replication factor is 2. Now your job tracker has decided to process block 1 here. Okay, job tracker has decided to process block 3 here. Job tracker has decided to process block 2 left, block 2 also here. Okay, now see, the datas are here. My MapReduce program will go here. Okay, and now the MapReduce program will try to act on the local data only. Getting my point? This is my cluster. Okay, block 1 is given to be processed here, block 2 to be processed here, block 3 to be processed here. This, let's say, idle block. Now when you write your MapReduce program, when you submit your job, we have just written our MapReduce program, we have submitted the job, so that will do what? That will send our Java program to your job tracker. The job tracker will now send the same program to this node as well as the same program to this node. In this node, that program will work on B1. In this node, that same program will work on B3 as well as on B2. Okay, whereas here nothing will happen. That means always the program will try to run on the local block. Okay, and it will never happen. Okay, it will never happen. Never means almost the chances are very few. It will never happen that the job tracker will ask this task tracker to process B2. Here it will not ask to process B2. Do I have a B2 block here? No. If the job tracker asks the task tracker to process B2 in this node, then what will happen? This B2 will have to be moved here completely. Okay, see, as per our diagram, this node is busy processing B1. This node is also busy processing B3 as well as B2. So why not let this job tracker ask the task tracker to process B2 here. Okay, and if it does so, then this B2 block has to be moved completely to this node. Getting my point? So this is called as going against the data local optimization. Data local means the local data will be always processed. The data will be processed always locally, and the data will not be moved. Clear? Now let's come to this picture. So this word 1 is present in data node. Okay, this word 2 is present in this data node. This word 3 is present in this data node. Alright, now this map slot worked on local data, agreed? This map slot also worked on the local data, because this word1.txt is sitting here only. Getting my point? Yes or no? Word2.txt is sitting, this data is present in this data node, and it has been processed here locally by this node. Okay, word3.txt, these three data are sitting here only, and it will be processed locally here. Okay, now in the map, if you see, the maps are always processing the data locally, is not it? But in case of your reducer, the data are moved. The mapper output is given to shuffle and sort, and then group, right? So after grouping it is moved, not after grouping, before grouping it is moved. So the map slots will give output, this map slot 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 will give output. After that it has to be sorted, is not it? So sorting can be done only at a single place or not? Can we sort it at different places? No. Sorting has to be done on the single place, right? So immediately after the mapping, immediately after the map slot is executed, the data is moved to one of the node where all the sorting and all will take place. Okay, the sorting will take place, then group by will take place, then the data will be fetched, will be given to the reduce slot. Clear on this? So my conclusion is, map slot always respect data localization, data local optimization, whereas reduce slots or reducer do not entertain local optimization. After processing, the file size will be reduced or not, that depends on what exactly you are processing. For example, let's say I just have a data of customer, and from there I just want to retrieve his only phone number. Okay, I don't want to retrieve anything else, first name, last name, mother name, father name, how many wives he has, how many childs he has, how many phones he carries, how many two-wheelers, what are the insurance he has done. Let's say we have a data of a customer like this, and out of that I just want to get the phone number, right? So if you want to get the phone number, then the data will be reduced to almost 95%. Whereas you need a lot of things, you need phone number, you need this, you need that, then again the data size will increase.